Okay, so Vesper Theory. Remember that Vesper is an acronym, okay? It stands for valence shell electron pair repulsion. That last part right there is pretty important, although the whole thing's pretty important. What this tells me is that if I've got pairs of electrons, whether they are in a bond or whether they are just lone pairs, they are going to repel. They're going to push each other away. And how they push each other away lets us predict the three-dimensional shape that a molecule can take on. Okay? In order to use Vesper, in order to predict the shape of a molecule, you have to start with a correct dot diagram. Okay? So if I want to know, for instance, what the shape of, excuse me, let's say that we have like, I don't know. Let's do dihydrogen sulfide, okay? H2S. First thing I need to do is I need to start by doing a correct dot diagram of H2S, okay? Which is a whole nother topic for review. Sulfur I know has 6, and according to my periodic table, sulfurs are in pair, pair, single, single. So I start off with pair, pair, single, single. I know that hydrogen only has 1 valence electron, so I'm going to have one of my hydrogens come make a bond right there. I'm going to make another hydrogen come make a bond right there. And so I can now use this using what we call the axe method, and then that Vesper chart to predict the shape this is going to take on. A is your central atom. My central atom here is my sulfur. Okay? I'm looking at the shape around that atom right there. X has to do with how many total branches I have. Okay? So X has to do with what's called my, let me see. Is X branches or is X steric number? X is steric number. Okay, so branches is going to be, no, X is not. Okay, it's just branches. So I'm looking for atoms that are coming off of the sulfur. Where do I have, or how many atoms do I have coming off that sulfur? 2. This one right here, and this one right here. So here, X is equal to 2. Okay? E is lone pairs of electrons. These are electron pairs that are on that center atom that are not involved in a bond with something else. Do I have any lone pairs on the sulfur? Yeah, I do. Here's a lone pair. That's an E. And here's a lone pair. That's an E. So my E here is going to also equal to 2 lone pairs. So then I use my Vesper chart, and I don't have a handy one to put up here, but whenever I look at my Vesper chart, I'm looking for steric number. Steric number is just equal to my X plus my E. I'm looking for the total number of all the thingies coming off of that middle atom. So how many total thingies do I have? I've got 4. I got 2 branches, and I got 2 lone pairs. So my steric number here is going to equal 4. So I'd use my Vesper chart. I would find the row where it says steric number equals 4, which is going to be my bottom row. And then it says across the top, how many lone pairs. And when I look at the intersection on my chart between steric number of 4 and 2 lone pairs, I find the place where they intersect. The place where they intersect on my particular thing has got an A with 2 X's and 2 E's, and it says the name of that shape is bent. And so that's the shape I go with. Oh boy. That's got to be good news. So does that, I mean, and honestly, it's just, you look at a single atom, you make sure you have a correctly written dot diagram, you count branches, you count lone pairs, you look on the chart to see what it looks the most like, and that's the shape. Okay. Any questions? And again, if you don't get all this down, that's fine. It is going to be in video. Okay, so that's Vesper in a nutshell. Any questions? Okay, that's one down. We've still got time. What else do you want to hear about? What? Quantum mechanics. Okay, like specifically the rules. Well, the good news is, Michael, like I said a while ago, I went over the rules this morning. It's going to be in a video that I'm going to. Where'd they go? It's going to be in a video that I will post later. Okay, so quantum mechanics, 4 rules, we're good. Okay, what else?
Noble gas configuration.
Noble gas configuration. Okay, cool. So talking about the different kinds of electron configuration, the one that does seem to give people a hard time is the noble gas config. And keep in mind for the noble gas config, it's kind of the shorthand or the short form of a full electron configuration. And a full electron configuration would be something like, 1s2, 2s2, 2p6, 3s. Anybody? I'll play the song again if you want to play the song. 4s2, 3d.
10.
There you go. Woo! And so on. Okay? That's the full electron configuration. Well, when you start getting to really big atoms, it gets really tiresome to write all that mess out. Okay? Let's say that I wanted to do the electron configuration for cesium. Okay? Cesium is element number 55. Which means I'm going to have to do all of this and show where all 55 electrons are. So it's going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4p10, 4d10, 5p6, 6s1. That's a mouthful. Now what I can also do is I can backtrack, kind of wind the clock back from cesium until I get to my noble gases, which is group 18. And if I back up just one from number 55, I come to number 54, which is xenon, right? Xenon's a noble gas. Now, everything up to the point of xenon, which would be everything up through 1, 2, 3, 4, 5p6. So it's going to encompass everything from 1s2 all the way up to 5p6 and all the stuff in between. I can replace all of that just by doing a xenon in brackets and then adding on what comes after that. And what comes after 5p6, if I look at my arrow diagram, is 6s1. So this right here is the noble gas configuration for cesium. I just took, instead of writing the whole thing out, I backpedaled to the last noble gas that came before it, and I added on what would go outside of that noble gas core. Okay, I can do another one if you like. Okay, are y'all good? While we're on the topic of electron configuration types, are there any of those other notation types that you have a question about? Or the sneaky way to know, kind of like I knew when I was looking at the periodic table there, what it would end with. Y'all remember how to do that? Okay, well let's look at that, because that's a useful skill. So I got my periodic table, the expertly drawn periodic table here. Okay, yay. All my dudes down here. So let's say that I've got an element. Oh, you know what? Let's do. Crud. Let's do silver. Okay. Silver's right here, right? Now, let me recognize the parts of the periodic table again. What do we call this piece over here? Nope. This whole piece over here is the S block, right? Okay. This part right here is what? That's the P block. This cat here in the middle is what? D block. And then these dudes down here at the bottom, that's my F block, right? So, silver is in which of those? It's in my D block. Now, looking at my color-coded periodic table, if I look at silver, it is actually in the portion of my D block referred to as 4D, correct? Okay, everybody looking at your color-coded periodic table that you labeled, okay? Because this is what I'm talking about, it's on there, okay? I look at this side,
Yes.
where I have color-coded all of my energy levels. My level 4 on this one here is green, and it's in 4D. Now, I'm going to start counting from the edge of that 4D until I get to silver. And so I count over 1, 2, 3, 4, 5, 6, 7, 8, 9. It's the 9th box over in 4D. See that? So I know when I write this, whether I write the noble gas or whether I write the full config, it will end with 4D9. Because that's where silver is on the periodic table. And from there, I just use my arrow diagram. Remember this cat with the 1s and the 2s and all that? So I just go 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, and here it is, 4d9. And that's the full configuration for silver. Okay? If I want to just do the noble gas configuration, then I back up from silver. And the last noble gas before I got to silver was Krypton. Krypton takes the place of everything from 1s2 up through 4p6. And so it would just be Krypton followed by the other stuff, which is 5s2, 4d9. Okay. I know it's been a while, but it's all still there. If you got this, you got your arrow diagram. If you don't have your arrow diagram, then you can just look the order you come to this. Okay, so here's level 1. We come to 1s, and we're done. Then level 2, we come to 2s, 2p. Then we come to 3s, 3p, 4s, 3d, 4p, and so on. Okay, it's in the same order that they're laid out on the periodic table. Does anyone have any questions about anything I just told you? Okay, we are just about out of time for today. Tomorrow we are going to be doing more of the same, so please take this home, start studying tonight, and and find stuff that doesn't get talked about, either stuff that doesn't get talked about in here, or also watch the videos for 5th and 6th hour. I'm going to be doing the same thing. Okay? See y'all then.